Hello and welcome to Chem News at 6. Our first story, a chemistry teacher threw sodium at one of our unruly students. In court, it was ruled assault. Later tonight, we'll be talking about a potentially historic climate change agreement. But first, here's our correspondent Rick Mercury with his take on global climate change and how it affects all of us.
As you can see, I have a can of H2CO3, or more commonly known as carbonated water. This first can represents the present. And this second can represents the future. As you can see, the concentration in the first can of CO2 is quite low, so it's not dangerous. But in the second can, the concentration is so high it becomes dangerous. Don't get me wrong, we don't want to get rid of all greenhouse gases because they're keeping us warm. But if they did disappear altogether, then we'd go into an ice age, and we know how bad that film was. But at our current rate, our fate is at a literal hell on Earth. Yes, the greenhouse gas effect is basically a blanket keeping us warm, but we don't want it so thick that it'll suffocate us. Or maybe we do. With all the senseless burning of coal and natural gases, it's almost as if we want to add another blanket to our layer. But I mean, look around. Couldn't we use it? You see, coal is an organic rock, or what we call a fossil fuel, formed from wildlife that lived millions and millions of years ago, making it a non-renewable resource. Today, coal is used in electrical generation and steel production, helping to keep us warm and to build bridges to jump off of, which we'll be thankful for if global warming continues at this pace. But it's not all sunshine and rainbows with coal, as the mercury in the air pollutants combines with the combustion of coal, relating to the loss of what's that word again?
Intellectual capacity.
In other words, global warming is making all of us dumber and dumber.
Get out of here.
Now, most people believe that global warming isn't real and that they don't need to do anything about it because, well, it won't affect us in this lifetime, so why do we have to worry? Good point. You know, I'll just pee all over this public toilet seat because I'll never use it again. These are the same people that drive to the gym just to get onto the treadmill. The truth is that global warming is impacting us today. It is squeezing the moisture out of the soil and ecosystem, just like the situation in California. It is predicted by that 2050, 40% of agricultural land will be unfarmable due to drought. This means a rise in world hunger, and more importantly, we won't have enough hay to feed our donkeys. So let's do the world a favor and fight global warming so we can save our asses and not be ones ourselves. More commonly known as carbonated soda. Oh my water. This first can represents the present. So thick that it'll
Suffocate us. That was great.
Unable to recharge all the time. Forgot how it goes. We're powering this flashlight. What's the second half? Electrical energy is then used to harness.
and fight.
Thank you, Rick, for that insightful message. Those poor asses. If you're feeling generous enough, feel free to call 1-800-SAVE-ASS, toll-free, to donate to the Saving Our Asses Foundation of Canada. Now on to today's top story, an event that could be, as Obama would put it, the best chance our planet has to combating global climate change. The Paris Climate Change Agreement took place on December 15, 2015, where over 200 nations agreed to cut down and eventually eliminate all greenhouse gas pollution. In it, they agreed to keep the global temperature rise well below 2 degrees Celsius in comparison to pre-industrial times. This is because climatologists and other experts have agreed that 2 degrees Celsius is a threshold to avoiding potentially catastrophic climate change. The ultimate goal of the agreement was for our planet to become completely carbon neutral sometime after 2050, but before 2100. This means the amount of greenhouse gases emitted by human activity is limited to a level where the trees, soil, and oceans can absorb it all naturally. Scientists believe that we will have to stop emitting greenhouse gases altogether within the next half-century to achieve this goal.
Wow, this beard is really great. I'm glad I grew it.
Oh! Shave off that nasty beard, weirdo!
Who, me?
Yes, you! Hey, what's up? Oh no! That was me! If you're me, who am I? Oh no! I just had the worst dream. Go back to bed, sweetie. Oh no! I married myself! No! Man. Get shaking the bed! Okay.
On the topic of global climate change, our final story of the night: can we use water to fuel cars? But first, here's our field reporter, chromium iodine sulfur, we call him Chris, explaining how standard run-of-the-mill batteries work.
An electrical cell is used to convert chemical energy into electrical energy. The electrical energy is then harnessed to perform day activities such as powering your vehicle or powering this flashlight. Batteries in your vehicle are secondary cells and are able to recharge over time to be used over and over again. The batteries in this flashlight are primary cells and are unable to recharge over time. Primary batteries are formed by combining two half reactions, one that undergoes a reduction reaction and the other an oxidation reaction where electrons are transferred when combined. In the cell where reduction occurs, a solid conductive electrode, also known as cathode, is submerged in its respective ion solution, and the cell where oxidation occurs, a solid conductive electrode called the anode is also submerged in its respective ion solution. In electrochemical cells, the cathode resembles the positive end, whereas the anode is the negative end. These two reactions are connected with the cell bridge to allow ion movement and an electrical device to be powered through electron flow. In spontaneous reactions, electrons flow from the anode to the cathode. Positively charged ions, or cations, move towards the cathode through the salt bridge, and negatively charged ions will move towards the anode. This same concept is applied to commercially available batteries that are more practical, such as these ones.
Thank you, Chris. Now on to the final, and what I believe is to be the most interesting article of the night: can we use water to fuel cars? How crazy would that be? Imagine a world where if you ran out of gas, instead of having to drive all the way to the gas station, you could just run the tap for a bit, and you're all good. This may become a reality in the near future. With the development of hydrogen fuel cells, water-powered cars, or more precisely hydrogen-powered cars, may become commercially available sooner than you might think. Now, fortunately, the process is quite complicated, and therefore expensive, so here's a simple breakdown of the process for all of you who have not taken chemistry 30. Sorry, what? Oh, all of our audience is chemistry 30 students. Oh, okay. Well, that changes things. Anyway, here's a breakdown of the process that is involved with the hydrogen fuel cell. Now, to put it extremely basically, a fuel cell is a method of generating power, but unlike other power sources, the only byproducts are heat and water. Sound simple? It's not. A technical term for the fuel cell is an electrochemical energy conversion device. It converts hydrogen and oxygen into water and creates electricity in the process. There are four main components to fuel cells: the hydrogen and oxygen gas, the catalyst that is required to split the gas into its atoms, the anode and cathode that is required to keep the atoms in place, and the membrane in between the cathode and anode that is used to regulate the flow of the ions. The pressurized hydrogen gas enters through the anode side, and when it comes into contact with the platinum catalyst, it breaks apart into two positively charged hydrogen ions and two electrons. The electrons are conducted through the anode and into the external circuit where it does useful things, such as run your car. Now at the cathode end, oxygen gas is forced into the platinum catalyst and is broken apart into two oxygen ions. The oxygen ions are very negatively charged, which pulls the positively charged hydrogen ions across the membrane, and there it is combined to form water. Now this single cell only produces around 0.7 volts of energy. In order to produce an effective amount of energy, we must make something called a fuel cell stack. This is when multiple fuel cells are stacked on top of each other to produce a larger charge. And now that that boring part's over, let's talk about something that's sure to keep you on the edge of your seats: the pros and cons of fuel cell cars. Now there are a number of complications when it comes to development of fuel cell cars. The first, economy. It can be harmful to the economy because it will replace all oil-based infrastructure, which would cost the jobs of many companies and their employees. It can also be costly. Hydrogen gas is not found in its elemental form here on Earth, and it is only found in compounds, so things like electrolysis must be done in order to extract it. Flammability. Hydrogen gas is extremely flammable and takes 14 times less energy to ignite than regular gas. The fourth is a storage problem. Because it would take a lot of hydrogen to run the cars, onboard storage containers would not fit into the current car models. The fifth and final complication is oxygen depletion. Because these cars would run on hydrogen, if there were ever a leak and the hydrogen were to leak into the car, it would react with all the oxygen to form water vapor. This would cause oxygen depletion and could lead to dizziness, headaches, or in the worst case scenario, fainting. Done. Oh wait, I have to do advantages. But despite all those complications, I still believe the advantages outweigh the complications. The first and biggest advantage is that the only emissions coming from the tailpipe are heat and water vapor, meaning greenhouse gas emissions will be reduced heavily. Second is abundance. Hydrogen fuel cell cars will run indefinitely if hydrogen is constantly supplied. A third is renewability. Unlike current non-renewable sources of fuel, hydrogen is very renewable and can be supplied on demand. Shaw.ca, sponsor. Well, that's all for tonight. My name is Bond, Hydrogen Bond. I'm not wearing any pants, and please join us next week for another segment of Chem News at 6. And remember, like our good friend Rick Mercury said, save the asses instead of being ones. Hello and welcome to Chem News at 6. Today's first story. This means that all human You want to get on your couch? Is it running?
Yeah.